So say we have CH3, COOH, aqueous. So it's in water, which is our solvent. It's acting as an acid, so it's giving off a hydrogen ion to water, forming hydronium ion, and forming its conjugate, which is missing its hydrogen ion. All right, so here we have an equation. And now we're going to introduce something which is the acid ionization constant, or Ka. And you'll be using Ka a lot in this course. We're also going to have some Kb's for bases. So the acid ionization constant. And it's an equilibrium constant, so you all know how to write equilibrium constants. So the equilibrium constant is going to be products, which in this case is hydronium ions, over times the concentration of the conjugate base of the acid over the conjugate acid. And there is no water in that equation, because here the water is pretty much pure. It's the solvent, so its concentration is not going to change very much. So it is left off. And I can tell you that the ionization constant here is 1.76 times 10 to the minus 5. Again, that's temperature dependent, so that's at 25 degrees. This is a small number. So that tells us this is not a very strong acid. So it's not ionizing very much in solution. That is a definition of a weak acid, something that doesn't ionize very much. The definition of a strong acid is something that does ionize quite a bit. So here then, we can write equations generically for acids and bases. You can write an equation generically, Ha being is your acid, plus water goes to hydronium ions, and your conjugate of the acid, which is A minus. So this is an acid Ha in water. We can also write it as Hb plus as an acid in water, going to hydronium ion concentrations, and the conjugate, which is base. It's lost its hydrogen ion as well. A strong acid is something that has a Ka greater than 1. More products than reactant at equilibrium. So that means it ionizes almost completely. So it goes far toward products, ionizes almost completely. A weak acid is something with a Ka of less than 1, which means that when you put this acid in water, it doesn't ionize very much, and so when you have equilibrium. So you can tell if something is a strong acid or not by looking at its Ka value, or alternatively, you can consider something called pKa. So the pKa is minus log of the Ka, and if you have a low value of Ka, you'll have a higher pKa, and the higher the pKa then, the weaker the acid. So you can look at Ka, or you can think about pKa in terms of whether something is a strong acid or not. And so we'll just finish up with this slide. So up here we have some very strong acids. These Kas are much greater than 1, and you have extremely low values for pKa. And if you keep going from strong acids, again, a strong acid has a Ka greater than 1, so these are all strong. And so then weak acids are less than 1. And so down here you'd have small numbers for Ka, and you have up here we have big Kas, here we have smaller Kas, and the corresponding pKas are going up. And if we keep going, this table is very long. We're going to get to some very high pKa values when you have some very, very small numbers. OK, we'll stop there for today and continue acid-base next time.